The last interesting piece that we haven't written down is the is subtype function. And again, what subtyping means is that when we have a posin 3D, we can use it where a posin is expected. Right? So posin 3D should be a subtype of posin. And the reason it's a subtype is, we could carefully reason this through, but it's really just because posin 3D extends posin. And that's why posin 3D can be used where a posin is expected. More generally, it's not just posin 3D and its immediate superclass, but a posin 3D should be an object, and so on. So the rule in general is an instance of a subclass is an instance of anything above it in the hierarchy. So we can get from posin 3D to object following lines, or we can get from snake to animal by going up in this tree. And that's why snake is a subclass of animal, or posin 3D is a subclass of object, or snake is a subclass of object. Again, if someone is asking, is posin a subtype of object? The answer is yes, because we can start at posin, follow superclasses until we get to object, which is what we were looking for. Right? Is object a subtype of posin, though? No, because if we start at object and follow superclasses, we don't get anywhere, and so we never see posin. So we don't get to posin starting from object, only the other way around, which is why posin is a subtype of object. Is object a subtype of itself? Okay, we're going to say yes. If you start at the top and try to go up until you reach object, well, you've already started there. So don't forget to check your immediate class before you look for a superclass. Is posin a subtype of posin? Same deal. You start at posin, so you immediately reach posin. So that is correct. Is tiger a subtype of posin? No, because we start at tiger, go up to animal, go up to object, and along the way, to get to object, we never saw posin. Notice that we have to stop either when we find the class that we were looking for, or because we've hit object and we're not looking for object, then that's when we have to stop. So, in other words, the is subtype relation is really about is subclass, at least if you have an object type. If you don't have an object type, then it's integers. Integers are only subtypes of integers. Just more generally, we'll expect that two types that aren't object types have to match exactly. But if they are both object types, then we can check whether the first one is a subclass as the second one. And the is subclass function works just as we were describing. We're going to walk up the tree starting from name to see if we hit name 2. So if we've already hit name 2, then that means name 1 is a subclass of name 2. If name 1 got to object and we were not looking for object, that means that name 1 must not be a subclass of name 2, so we return false. Otherwise, we go look for name 1, find out its superclass, and see if the superclass is a subtype of name 2. That is, this is walking up one step, since we weren't already at the right step. So here we will either hit the class that we were looking for, or eventually stop with object.